Welcome to qnawire.
We're told that an automobile engine is produced using piston rings that have a total mass of 100 grams, and this includes 9.4 microcuries of iron 59, which has a half-life of 4. Eventually, we want to find how the activity of the engine oil has changed and how much mass is worn from the piston rings per hour of operation. But to start, let's just find the decay constant in this case. This is given by the natural log of 2 over the half-life. And for us, this gives a value of 1.78 times 10 to the minus 7 inverse seconds. So now we can calculate the activity after 1,000 hours. So the activity after 1,000 hours is just given by the initial activity times the exponential of minus lambda t. T, again, is 1,000 hours. Keeping careful track of our units, we find that this gives a value of 1.83 times 10 to the 5 decays per second. Now we know that the activity of a radioactive material must be proportional to its mass. So this tells us that the mass of the iron that was drained in the oil over total mass of the piston is going to be proportional to 84 decays per second, which is, we are told, the activity after it's run for 1,000 hours, over 1.83 times 10 to the 5 decays per second. So this tells us that we find a ratio of the mass of the piston worn to be 4.59 times 10 to the minus 2 grams. And since the piston was worn for 1,000 hours, we simply divide this by 1,000 to find that 4.59 times 10 to the minus 5 grams of the piston worn down per hour. So this is our final answer.